session today, it's kind of some new content. It's a new talk, an idea I'm experimenting with. So you're kind of guinea pigs in that sense. So I'm interested in particularly from a feedback perspective. It's kind of trying to scratch an itch that I have around a popular metric in our industry and having some more frank conversations about it. So it's talking about a metric called flow efficiency and talking about whether it's a panacea or a pipe dream. And if you don't know what those things are, don't worry, I will explain them in the talk. Bit about me, as mentioned, Agile coach here at ASOS.com. So we're an online fashion retailer. Hopefully you've bought something from us. Been here 18 months. Before that, worked in financial services, professional services, retail, logistics, and been doing agile roles for over 10 years now. And as a coach, I am particularly passionate about the use of data and metrics and using that to storytell or get better insight around improving our way of working. At ASOS, we've got anywhere from 100 to 120 teams. Technology makes up a third of the organization. And we let teams choose their own way of working where it aligns to agility and where is right for their context. So some teams do Scrum, some teams do Kanban, some teams do a blend of those, some teams do XP, DevOps, etc. We're not religious about what particular method teams use, but certainly we don't advocate for things like SAFe. And yeah, it's all about kind of continuously improving their way of working. And as coaches, there's only a few of us, so we only go to the parts of the organization that actually need the help and want to improve. A lot of our teams are proficient from an agile perspective. So that's kind of the boring stuff about me. And talking about flow efficiency. So a landmark book in the agile world that maybe some of you have read it, maybe some of you haven't, or this will be your first time hearing about it, is this book on the bottom left corner here from Don Reinson and the Principles of Product Development Flow. And it's a really good book, albeit it might take multiple attempts to read it. It took me about 5 attempts to get through the book. So it's quite heavy going. And it's all around kind of being more effective in product development and kind of combining lean and agile thinking. And one of the quotes from this book from Reinson is around how our greatest waste is not unproductive engineers, but work products sitting idle in process queues. So basically work that is sat there waiting, and that is our greatest waste in product development. And another quote around kind of waiting and waste and efficiency is from Dominica de Grandis. She wrote the book Making Work Visible. If you want an easier read, I'd recommend that one. So this is all around, her book is all about exposing things like when we're losing time, when we have high work in progress. And in that book, she talks about, well, if you measure anything, measure weight. And what happened in, I'd say probably the last kind of maybe 5, 6, 7 years is the growing popularity of a metric called flow efficiency. And if you aren't familiar with it, flow efficiency is basically when you calculate the amount in terms of a percentage time spent actively working on items versus the total time. So if you had a workflow like is shown in the visual in front of to do, development, code review, testing, deployment, and done, you've got subcolumns there of in progress and done. Anytime you see an in progress subcolumn, that's where you would calculate active time. Anytime you see a subcolumn of done, that's waiting time. So if an item took 10 days to go from development to done, and only 5 of those was when an item was spent in an in progress subcolumn, then that would have a flow efficiency percentage of 50%. And you'll get a copy of the slides if you want to read about it and any of the sources. They're all referenced. You can read them in your own time. And then when it comes to flow efficiency as a metric, visualized as data, this is how it's most commonly represented. So on your x-axis, you have a flow efficiency percentage, so the axis at the bottom. And then on the left-hand side, your y-axis, you have the number or frequency, the number of work items that had that flow efficiency percentage. So here you can see the vast majority of items are towards that kind of tail end, getting close to 100%. And then you've got this chart in the top left, and it shows you what the average flow efficiency was month on month for that given period. And in terms of how it's kind of talked about in the industry, many people will talk about flow efficiency as a panacea. And a panacea is basically something that will solve all problems. And the reference there is technology is not a panacea for all our problems, but from a measurement and a metrics and visualization perspective, many consultants, well-known people in the industry will talk about how flow efficiency is the thing to go after, the thing to measure. Things like value stream mapping would advocate for it as well. And that's the thing that you should be tracking as an organization. And when it comes to industry standards for flow efficiency, so what are the typical numbers that organizations see? So you could argue this is a measurement that spans across different contexts and is agnostic of context. One of the articles that was written a couple of years ago says that the industry standard is anything between 15% and 40% flow efficiency is good, and flow efficiency above 40% is considered exceptional. Another blog, similar theme, this is from the Scrum and Kanban blog. This was written in 2015. And this is again talking about, well, what percentage of your team's time is spent actively working on items? And this one's saying that as low as 2% and as high as 40% is what's been observed. And these are kind of the numbers that are seen. And then the final one, I had to go back into Web Archive to find this one. This is from David Anderson. Hopefully most people know who David Anderson is. Guy who kind of wrote the very famous Kanban book and is kind of the founder, I think, of Lean Kanban University, although I don't think he's as involved now. And he's got a blog about, well, who is your vice president of delay? And it's all about talking about wait time with items. And he's saying that flow efficiency, as low as 2% has been reported by managers and consultants reporting at Lean Kanban conferences. And his own personal experience is that he sees anywhere from 5 to 15% flow efficiency. And even when you invest a lot of effort, 40% is still very good based on his experience and what he's seen. The problem with these three blogs is that they don't actually include any tangible reference to any studies or any supporting data that give credit to those industry standards or numbers that they quote. So David Anderson, one that mentions very anecdotal feedback. The other two blogs, they don't actually have any supporting information around flow efficiency percentages. And I think that's important because when we're talking about something where we have industry standards, we need to be more open to challenging as to how those numbers have come about. And the hashtag I quite like to advocate for is hashtag data or it didn't happen. So people can talk about these numbers that they've seen, but unless there is supporting information that backs that, be mindful of the numbers that you see that are presented in conferences or are talked about anecdotally in blogs. And when I was kind of doing my research around flow efficiency and exploring this as an idea, I managed to come across one journal that actually did have some numbers around flow efficiency. And the paper is called Process Efficiency, Adapting Flow to the Agile Improvement Effort. So it says process efficiency, but it's using it interchangeably with flow efficiency. And in the paper, it talks about, well, the average Scrum team process efficiency or flow efficiency for completing a product backlog item is on the order of 5 to 10%. And reading this, I was like, okay, this sounds really promising, and actually we've got some good data around it. But then when you read further in the paper, you understand the source around this information, which is according to polls of participants in Scrum classes in the US and Europe by one of the authors. So this is essentially asking people to put their hand up in a training session. This isn't a valid data point and shouldn't be taken as an example of what flow efficiency percentages typically are. So if anyone cites this, be mindful, this is the supporting source around this information. And kind of, where I think a lot of organizations are, and when I was researching this, is kind of wanting more solid information around what is actually seen and experienced by people, supported by data. And it's a kind of a little bit like the game show Family Fortunes, if anyone's heard of that. So this is where I think it's 100 people are surveyed, and there's a question that they're asked, and then they give the top 5 or top 6 most popular answers, and the audience, the people taking part in the game show, they have to guess which answer was the most frequently suggested by people. So in this example, give me a word starting with sand. It could be sandpaper, sandwich, sanity, sandbox, etc. So where I think we need to get to as an industry is having more solid information around what is a typical flow efficiency percentage, so that if people are measuring it, they have something more solid from a data perspective they can call on to validate where their team or their organization is at and what are the numbers that we're seeing. So what I did as part of this, given that we have so many teams at ASOS, is look at our data. So flow efficiency is one of the things that our teams can track amongst all the other metrics that they can use. So they have a chart called flow efficiency, and they use a drop-down filter to select, well, what are their work states on their board, so their active states, and then you'll see the visual kind of dynamically updates. So each dot represents an item that's completed in that period, and you'll see the range of kind of orange to blue. So orange is items that had a very low flow efficiency, so close to that kind of 0%, and the blue items are ones that had very high flow efficiency. And then what they can do is they can hover on a particular data point, and they get some information around what the item was, when it was completed, and what the flow efficiency percentage was for that particular item. So they can use that then to do some further investigation, if they will. And what I did kind of when looking at this information was playing around with different time horizons for different teams and tracking in terms of that flow efficiency value that is seen at the top, that's going anywhere from 21 to 24 to 23%, and looking at the ranges of that across teams and seeing what was the minimum value that teams saw and what was the maximum value that teams saw, and doing this for a bunch of teams to get some better data around what flow efficiency values do we actually see. So in terms of the study, so we looked at 63 different ASOS teams. Like I mentioned, teams use a blend of practices, and we have a combination of teams that are building things that are customer-facing products or services, so things like when you save an item to your basket, versus teams that build stuff for internal systems like the software that we use for doing fashion shoots in our studios. And nearly all our teams are stable, so we don't really have project teams, but I wouldn't say that we have product teams as such, because we're not there yet in terms of thinking this way as an organization. But certainly we keep teams together and keep them stable. It's very rare that a team delivers something and is disbanded. And on the right-hand side, you've got all the different teams and what the minimum flow efficiency was in the period that I looked at, and what the maximum flow efficiency percentage was in the period that I looked at. And this is kind of what the numbers say. So this is a dumbbell chart. If anyone didn't know what the visual was, hopefully it's pretty obvious in terms of why it's called a dumbbell chart. So you've got the two ends where the weights would be, and then you've got the bar. And it's used to kind of communicate ranges in data. So here you're looking at what was the lowest for the team in the period and what was the highest. So from orange to blue. This dashed line represents the average across all the teams. And you can see the range going down to kind of teams that had the lowest flow efficiency recorded, the teams that had the highest flow efficiency recorded. And you might be watching this and struggling to keep up in terms of, well, how do I actually read that chart? Can you pause it? I can't quite see what that means, what happened with that team, etc. So what I've done is kind of simplified the findings from the research and what it showed. First being that when we talk about flow efficiency and the numbers that were recorded, you'll remember some of the stuff that said around the lowest recorded was 2% and the highest recorded was over 40%. In terms of the flow efficiency range, in terms of values that were seen, the lowest ever seen across all the 63 teams I looked at was 9%, and the highest flow efficiency seen was 68%. So when we talk about what flow efficiency values can we see, what is the range, this is what I saw across the period, across the teams that I looked at. The second thing is looking at, well, what was the average? And again, so when you think about, well, what's the average flow efficiency seen? And people say, well, typically 5 to 15%. And the average across the 63 teams that I looked at was 34%. So maybe towards that higher end of what is typically seen. But across the teams that I looked at, the average seen is 34% when we look at the range in those values. Another thing to consider is that all teams had variation in their values. And actually, 38% of the teams, so 25 out of the 63 teams, they had a flow efficiency range in terms of lowest to highest of greater than 10%. So any time that you hear someone talking about, if they say, I've seen flow efficiency values that are typically 5%, and they talk about it as a single number, I would treat that with extreme caution and skepticism, because we know from looking at this information, flow efficiency is a range. It's not a single value. So when they're talking about, well, I typically see this, I would be doubtful as to how much information they have actually seen around it. And also when people talk about the ranges in flow efficiency, if people say, well, we typically see 5% difference, so anywhere from 5 to 10%. Again, I think we have to be skeptical of that, because nearly 40% of the teams that we looked at, they had a range of greater than 10%. So is saying it's between 5 to 10% actually accurate? And some of the previous quotes around kind of what the industry standard is, and saying anything between 15 and 40% is good, above 40% is exceptional, as low as 2% recorded, and typically seeing 5 to 15% flow efficiency. If we were to take some of these quotes and we were to categorize them based on what is typically seen, then the teams from this study would look like so. So we would have no team in ASOS that has a low flow efficiency, less than 5%. We would have only one team that has a medium flow efficiency of 5 to 15%, and the vast majority would be in the high range of 15 to 40%, or the very high range of over 40%. And I think as an industry, we need to move away from this idea. Based on looking at so many teams, I don't think this is an accurate representation of what low, medium, high actually looks like from a flow efficiency percentage perspective. I think it would be better saying low is less than 20%, medium is 20 to 40%, high is 40 to 60, and very high is 60% plus. There's no doubt that we are more advanced as a technology organization, particularly through things like microservices and investing many years ago in the cloud. But certainly plenty teams here still have dependencies on other teams, and therefore, by that very nature, flow efficiency is going to be lower than expected. So I think when we're talking about industry standards, this is the kind of thing that we could move towards. And that summarizes flow efficiency, but not really. The second part is all around, well, this concept of a pipe dream. And I believe that flow efficiency is actually a pipe dream in terms of a metric. And I think it's an idea that it reads good on paper and is good to sell to organizations, if it's a coach or a consultant, but it is practically impossible to put it into practice. And in fact, even if you do, it's probably not that helpful, and there are better things you should be looking at. So really, I think flow efficiency is not realistic, and it will never be more than a pipe dream. And why do I say that? Well, for one, plenty of teams that I have worked with over the years do not have wait states modeled in their Kanban board or in their process or in their workflow, whatever you want to call it. So by that very nature, all the items that this team work on would have a flow efficiency percentage of 100%. And that means kind of all that information is pretty much useless, because there's no way that that time was spent 100% of the time working on an item. And let's say if we work with this team and we remodeled our workflow and we had our wait states and our active states modeled, and then we were tracking flow efficiency from that perspective. Again, we start getting into challenges around, well, you can have people that stand up, say, well, I finished that yesterday, but I actually forgot to move it. Or, well, actually, I started that on Monday, but I've been in meetings, or I went on holiday, I didn't get a chance to update it. And therefore, the items are not getting real-time updates, and therefore your flow efficiency metric, if you're wanting to track active time and wait time, is abundantly flawed. Just like when people go home at the end of the day, that work, well, the work that is in an active state, it'll stay in an active state. But people don't put everything in a wait state when they go home at the end of the day, do they? Because that wouldn't be effective, and that would be a really frustrating way to work. But if we're not doing that, then the flow efficiency value is immediately going to be skewed by the amount of time that is on an evening or a weekend. And we shouldn't be working at that time, of course we should. But the number that flow efficiency is producing, we have to treat that with healthy and heavy skepticism, because it's not an active reflection of how much time was truly spent active or how much time was truly spent waiting. Another reason that it's a pipe dream of metric is around being blocked. So in this instance, a team is working on something and they need stakeholder feedback before they can move it into testing or move it to the done sub-column, and therefore it's blocked. But this is sat in an active state in terms of our flow efficiency calculation, but we're not actually working on it. So therefore, why is that being counted as active time? And I think this is an important thing. When you read about flow efficiency, plenty of the blogs out there will not talk about including time being blocked as part of your flow efficiency calculations. So an example being TaskTop tool is very big on value stream mapping and flow efficiency. And they have this example in one of their blogs. So something that's in design, waiting for triage, defining, ready, in dev, etc. There are plenty of times when things are in development where teams get blocked. And that is not depicted in this visual. All this visual is depicting is the different steps in the workflow. It's not talking about when development gets blocked. So not accounting for that time and saying this is how you calculate flow efficiency is not a true representation around how many days or how many hours we're spending working or waiting on an item, because it applies both ways. You know, you could mark an item as blocked, you get unblocked by the other team, and then you don't have capacity to start it because you pick something up. So it's not really blocked, but then if you include blocked in your calculation, it starts to get very messy. The fourth reason is the concept of number one. So number one is a sketch from a British comedy show called That Mitchell and Webb Look. And this is where participants would shout out random numbers to a game show host, and they would get points. And they would just say 2, 4, 9, and the host would go, that's number one, and you can look it up on YouTube if you want to. And at one point, it gets to where contestants are just making up new numbers in order to get points. And well, how is that relevant to flow efficiency as a metric, as a measurement? Well, if we take 2 examples of items that a team has been working on and has completed, we've got our Face ID login user story, and that had a flow efficiency percentage of 19%. And our QR code return story had a flow efficiency percentage of 9%. So Face ID login was more efficient than our QR code return story was. But that's simply not true. It's just a number. It's just a percentage. If you look at the cycle time for those items, they're actually nearly half the time taken. So from an efficiency perspective, a customer, stakeholder, person waiting on that feature or that functionality being built, they don't care about how efficient an item was. They're going to care about how long it took. And they would always say that an item that is quicker is more efficient than something that spent more time in active state on a Teams board. And similarly, this doesn't really give you any insight as to, if you wanted to improve flow efficiency, what should you be looking at? It's just a number. It's just 19%. It's like, so what? Where should I be looking to improve our workflow? Why did it get blocked? Why was it waiting? This doesn't give you any insight in the answers to that question. Another flaw around it is it averages. So just like the visuals that you saw previously, people aggregate it and put it as an average. And that's where we're into kind of floor of averages territory, where by aggregating things and looking at the average, we're missing out on learning and opportunities to improve our way of working. So these top 2 items, they have a very high flow efficiency percentage, but the 3 items underneath that were completing that period, they have a very low flow efficiency percentage. Now, if we were to look at what the industry standards say around flow efficiency, you'd be looking at this and thinking this is very good. Industry standards say the best are at 40% or higher. We're at 30%. That's really good. But actually, it's not really, because 3 out of the 5 items took way longer were far less efficient than those 2 items at the top. So we might be saying, well, this is good. We don't need to improve flow efficiency. But actually, you should be focusing on those 3 items as a means of improvement and finding ways to get better. And then the final reason why I think flow efficiency is more of a pipe dream is we don't really consider or quantify the true overhead that comes with tracking flow efficiency. So if you were a member of this team and this is your workflow, so from backlog to doing some refinement, stuff that's in a ready queue, it goes into development, ready for testing, test, ready to release, done. So there are 8 columns on our board, which means there are up to 7 transitions that an item could take in our workflow. So let's just say we look at 30 work items in a given period. Let's say it's the number of items completed in 4 weeks, for example, or a couple of sprints if you're using Scrum. And let's say, okay, let's say kind of 60% of these items, they go through all columns on the board. And then let's say 40% of the items, they could vary in terms of skipping columns. So they might just go from backlog to analysis to dev to test to done. But let's kind of randomize that. So 60% of them, they go through every column, and then 40%, they kind of fluctuate in terms of the number of column transitions they do. And then let's add a little bit more onto that in terms of commenting on items. So I don't know what it's like in your organization, but certainly in ours, teams like to comment on tickets. So that could be mentioning when something's not broken or getting someone to have a look at it. So again, comments, you can have a few on a ticket, you can have not many. So again, we do a little bit of randomization here as to number of times a work item gets a comment. And then we look at, okay, well, all the times that work gets blocked, and again, kind of randomizing it. Sometimes something doesn't get blocked. In most cases, something gets blocked. So saying this can happen anywhere from 0 to 3 times, but also the time when you need to unblock something. So you get unblocked, you'd go into your tool, you'd mark it as unblocked, and you'd maybe change swim lane, change column it's in, depending on how you go about blocking. And then let's say we're going to add in when we're waiting for feedback on someone. So this is when we start delving into the true overhead of tracking flow efficiency. So if we were to be serious about all the times that we're waiting, that's going to happen frequently on items. So let's say we're waiting for a response, so we're going to mark it as waiting. Maybe we've got a waiting swim lane. And then let's say sometimes when stuff gets marked as waiting, we're going to add a comment as well as to what we're waiting on. And again, each of these times you're doing this, you are updating your board or your tool of choice, so you're having to go in and do something. When we look at them side by side, and this is, bear in mind, this is just for 30 items, so that might take you a couple of weeks to get through that, or it may take you a couple of months. The number of updates that will be needed to a board in terms of a team's tool of choice be close to about 350, so 348 times. We would have to go in and update our board without tracking any waiting time. So just tracking when stuff moves between columns, when we add a comment, and when we're blocked, which tends to be how most teams work. Now, if we were to be saying, okay, we want to better track or get a more accurate flow efficiency number, that's when we're adding all the time where we're waiting. And you can see it takes nearly 200 more updates to the board in order to track that in looking at 30 work items. Now, if you were to say, well, if you do 30 items in a 2-week period, multiply that over a year, and then let's say you've got 30 software teams, you then start to see the true overhead of tracking flow efficiency and getting an accurate number. You're talking probably thousands and thousands more updates in your tools to get that number, which probably isn't an effective use of your team's time. They just use these tools for kind of high level tracking of things. If you're going to get so granular, you want to track the time spent waiting and not waiting. The overhead and the burden this produces on teams is significant. And I challenge any advocates of flow efficiency why they don't share this information with organizations where they're selling flow efficiency. And my guess is because it's an oxymoron, and that is, this is not a more efficient way of working. Going into your tool 200 times more for a period for these 30 work items, that isn't more efficient as a way of working. It might give you a more accurate number, but it's ironic that the number is around efficiency when this isn't an efficient way of working. So what should you track? Because it's kind of like, fair enough, I've abused flow efficiency long enough. What are some of the things that you could consider or start looking at? One of the things that we do with our teams is we focus on things like blocker metrics. And most of our teams, this is when they tag something as blocked and then they untag it when it's unblocked, or they label it depending on what tool they use. So here we got things around, well, what are our current blocked items? How long have they been blocked for? We've got things around trends as to how frequently are items being identified as blocked? How long does it take us on average to unblock things? And we're talking about the flaws of averages earlier. When you're looking at averages from a trends perspective, it's not as bad. So here you're seeing this team, blockers are happening more frequently, and it's taking them more time on average to unblock them. And then finally, just looking at, well, what's the proportion of time spent blocked versus not blocked working on an item? And again, this is just through adding a tag to items. It's not through all the marking it as waiting, not waiting, etc. And then what some teams do, taking it further, is they start looking at, well, what blockers happen the most frequently? So it may be there, depending on other teams. This team, they use the concept of BAU when they're blocked. So this is where maybe we've got a promotion on as an organization. Let's say it's 25% off. That means there's higher traffic to the website, and that means some new features that they want to deploy. They can't do that because we're in a period where we're reducing the amount of change we're introducing to users. And looking at frequency is one thing, but impact is the other side. So just because a blocker occurs frequently, it may not be impactful as those that occur less frequently, but be more time being blocked. So again, it gives a bit of balance as to, well, which happen the most, but which have the most impact in terms of slowing us down. And then another thing you can use is start to use this to tell a story around data and where you're improving your way of working as an organization. So if you're a coach, really, I think you're focusing on removing impediments and reducing the amount of blockers that are occurring. This use of, it's called a slope chart. Hopefully it's fairly obvious why it's called a slope, an upward or downward slope, comparing month on month. So we can see that for organizational blockers, third-party technical and tooling blockers, between May and June, they have decreased. They're sloping downward. So that means those blockers are happening less frequently. But also we're getting insight as to, well, where should we be focusing next? Those things that are sloping upward. And in this instance, it's looking at environment, looking at access. Those are the two that we should be focusing on next because they're increasing. So it just, again, makes it easy for us to visualize where we're getting better and where we need to go next. And that kind of summarizes the talk, really. So flow efficiency is a measure of the percentage of active time spent working on items, and it's celebrated in the industry as a metric that you should be tracking. And it's a true measure of, I guess, the agility of a team or organization. But it's flawed in its industry standards. They don't have any data supporting them. And also the many problems that come with it as a calculation. And what you should instead try are things like blocker metrics and using that to focus on improving your way of working. And with that, I can stop sharing and we can go to questions. Thank you.